All right, everybody. Inequalities, we're adding and subtracting. Is everybody ready? Here we go. Hi, everybody, and welcome back. Today, we're looking at adding and subtracting rationals. Nope, not at all. Cut. Undo. Hello, everybody, and welcome back. Today, we are looking at adding and subtracting inequalities. Or maybe I should say solving by adding and subtracting inequalities. And if you haven't checked out my other inequality videos, you want to be looking at those. And really what we need to be thinking about is this is nothing crazy. It is the exact same thing as just regular solving. So the first thing, of course, is just relax. This is the exact same. It's the same as regular solving. There's only one little difference. Instead of seeing questions that say things like x plus 2 is equal to, say, 8, we are going to start to see some different things now. We're going to change that equal sign, and we're going to see things that say like x plus 2 is greater than 8. So the difference here is I'm just simply asking you, for this one, I'm asking you that if it's an equal sign, we're saying specifically, what is x going to be? What is it exactly going to be that is going to make this statement true? Like, how do you make it true? That's really what you're trying to do. So what does it have to be? Well, for this one, I think you can probably say that if this was 6, then that would make it true. Yay. Well, over here, how do you make this one true? This says a number plus 2 is going to be bigger than 8. What could it possibly be? What could it possibly be? Well, could it be 6? This is a trick question. Does this make it true? Does it? Nope. Because 6 plus 2 is 8 greater than 8? It's not greater than 8. It is not. We need to know all the numbers that would make it bigger than 8. So would 6 work? No. But I do know that 6.01 would make this true. I also know that 10 would make this true. I also know that 2001 would make this true. There's a lot of things that make it true. So for inequalities, we can't write down all the different answers, so we have to answer with an inequality and give you a range of possible outcomes. The process is exactly the same. So the process is the same as we would do our regular solving. So again, if you haven't watched any of my videos about solving, then you want to definitely be going back and doing that. Because let's be honest, does it get better than watching old math videos? No. And just imagine, so I want you to imagine, just imagine, it's an equal sign. And continue on as you normally would. Now, depending on your style, you may want to go and do the two sides thing. And we want to get x all by itself, so I'm just going to go subtract 2 from both sides. And there we get the answer. X is now greater than, it is a greater than sign, is greater than 6. Cool. Now your teacher is going to ask you to go and graph this one. So again, previous videos we talked about graphing. But the way that I graph is you put that answer in the middle, and you put a number on either side of it. So 7 here and 5 here. Now ask yourself, is it an open circle or a closed circle? So that little 5, there we go. It's going to be an open circle. And its x is bigger than 6. So where are all the numbers that are bigger than 6? They're this way. So we got to go and show that. And there you go. Let's see some different examples, just to make sure that we are all getting this. So let's get rid of that. Boom. And let's get some other questions. So let's just say you had, I don't know, -7 is less than x plus 4. Sure. I know, kind of crazy. The x is on the right-hand side, but don't fear, don't fear. We're going to go on two sides. I'm going to subtract 4 from both sides. And here, we're going to say -11 is less than x. Now, in other videos, I've told you one thing. When kids go to graph this, they kind of find it wonky. I want you to think about, if you need to, you could flip it like a mirror. So think of the mirror image of what that is. And in specifically, I want you to pay attention to what is the alligator eating. So what is this alligator eating? It's eating the x. So when you flip it, the alligator has to keep eating the x. So if I flipped it, that alligator continues to eat that x. And there we go. Now this is going to be easier for students to graph. X is bigger than negative 11. So again, we put the answer in the middle. Oops. There we go. Put that answer in the middle. Put a number on either side. Negative numbers, be careful. To go the right way. It's an open circle. And of course, what are all the numbers that are bigger than negative 11? They're on that side. You know, little top trip. If your variable is on the left-hand side when you do this, so is the letter on the left-hand side? It is. Look, it actually literally makes an arrow. Do you see that? How it actually makes the arrow? And look, there's the exact same arrow. So you always know the direction that it's going in. This is pretty good, right? You're like, wow, that's a good top tip. It is, right? Yeah, I like my job. Here we go. Let's just do one more. So this is just adding and subtracting. Maybe I'll just throw in this kind of stuff just to make sure you're paying attention. There we go. And for this one, make sure that you are changing it. That double negative does become positive. And we get 12. And I'm going to go and solve this by subtracting 2 from both sides. And x is less than or equal to 10. Great. Graph it. Put 10 in the middle. Put 11 over here. Put 9 over here. This time it's going to be a solid circle. And my arrows are going to go to the left. There we go. Now let's go on to some more trickier stuff. So let's go and talk about compound inequalities. And we do want to be talking about these because you are going to see these. Now these are going to require you to have a couple of different colors. That's right, you might want to pause the video right now and go and grab your favorite colors. I am a big fan of green. I love green. And what else am I going to use? I mean, yellow makes me happy for sure, but green, maybe I'll use red. Sure. Let's get a couple colors. So compound inequalities are basically where you have two, how would I say it? I don't know, I'll say two things written as one. So that's what a compound inequality is, two things written as one. Sure, that'll go for my definition. There's probably a better mathematical definition. I'm going to show you an example, though. An example is always going to be the easiest way. So negative 5 is less than or equal to x minus 4, which is going to be less than or equal to 13. Now you can see right away, what do you notice right away, is that there are two inequality signs. There's one here and there's one here. When you see that, that means it's a compound inequality. Okay? Well, that means you are going to get two statements. Two statements that we must solve independently. So we get two statements that we're going to solve separately. So I'm going to show you how to separate them. This is where the colors come in. So we're going to go and grab our green. I'm going to show you how I'm going to draw it. You're going to start drawing a box, or a rectangle, all the way until you get to the second inequality sign, and then you stop. Because one inequality can only have one inequality sign, only one. You can't have two. You can't do that. So you're going to get that one. Then you can get your red pen. You're going to start from the other side. And you're going to draw another rectangle. And this time you're going to go around and you're going to stop at the second inequality sign. And those are your two statements. So inside the red rectangle, you have x minus 4 is less than or equal to 13. And inside the green rectangle, inside that green rectangle, you have negative 5 is less than or equal to x minus 4. Now you're going to go and solve those two things completely separately. And at the end, we're going to put everything together. So let's go and do that, shall we? Let's go and solve it. We know how to solve these now. We're going to add 4 to the side and add 4 to the side. And what do we get? X is less than or equal to 17. And over here, let's go and solve this one now separately. We're going to add 4 to this side and add 4 to this side. And we are going to get negative 1 is less than or equal to x. I'm going to do the quick little mirror flip thing. I am going to do the quick little mirror flip thing. And I'm going to write it as x is greater than or equal to negative 1. I'm just going to do that just to make this a little bit easier. Okay, now we need to go and graph it. We need to graph them both on the same graph. So I'm going to do my graph. Now this is always a little bit trickier. I need to have both of these numbers kind of represented. So where is 17? I'm going to put 17 here. And I'm going to put negative 1 over here. I am going to put numbers on either side of those. So this does take a little bit more number work. So this would be a 0. This would be a 16. And this would be an 18. And this would be a negative 2. Okay. Let's go and graph this x is less than or equal to 17. So here's this one. Oops, let's go get a different color. There you go. So solid circle. And it goes this way. So this says x is smaller than that, right? Well, the other one says x is bigger or equal to negative 1. So I'm going to get a different color here just to make life a little bit more fun. And I'm going to say, here we go. Solid, and it goes this way. See how they're crossing? Like that? So really, that would be all numbers, wouldn't it? But because this is a compound inequality, we want to show the answers that satisfy both conditions. So, what part of the graph satisfies both conditions? Well, I would say from here to here satisfies both. So what you actually graph for an actual answer is the red. On your screen right now, that's what your actual answer would be. You would just leave the red. You'd erase the yellow, you'd erase this purple, and the red. It looks like, I call this a barbell. You get like a barbell looking answer for a compound inequality. Would you like to see another one? Yes? Okay. Let's do another one. So here's another example. This would be your last one. Negative 12 is less than 2 minus 5x is less than or equal to 7. Now this one is going to be a multi-step inequality. And there's going to be a little bit more to this one. But let's just go and tackle it. Remember, you can get two different statements. You get the one obviously in the very nice yellow box, and you're going to get this one. And you just basically stop before the second inequality sign. So here in that kind of turquoise box, you got 2 minus 5x is less than or equal to 7. And in the yellow box, you ended up getting negative 12 is less than 2 minus 5x. And you solve both of these independently. And you put the graph together all together. Cool? Cool. Let's go and solve this one. Now I'm going to go and solve this one right now. Now, as I've written this question, I'm already like, oh no. Do you know why I'm saying oh no? Because there's going to be something I'm going to do in a second that's going to make you say, what just happened? Well, in order to get the x by itself right now, what do I need to go and divide by, everybody? Negative 5, don't I? Well, there's a special rule when you divide or multiply by a negative. When you divide or multiply by a negative number, and you'll see this in my other videos about multiplying and dividing inequalities, you actually have to go and change that sign. You have to go and flip it. So I am going to go and flip it because that's what you have to do. But don't freak out. Just say, okay, that's a rule. I haven't gone over very much. So I'm going to go and flip it right now. And it becomes greater than or equal to, what does that be, -1. So there's my answer there. Guess what? The same sort of things are going to be happening over on this side. So let's go and solve this one. I'm going to subtract 2 from both sides first. Always do your adding and subtracting first. I'm going to get -14 is less than -5x. And I'm going to go and divide both sides by -5. So I'm going to go do that dividing by negative thing. That means I got to go and flip the inequality sign. It means I have to go and do that. So I have to go and change this. And this becomes just x. And this becomes positive 14 over 5. Like that. Which is actually what? This is approximately, I'm going to change this. Watch what I'm going to do. I'm going to go and change this. This is what? 2 8/10. Something like that. About 2.8 is less than x. And then, oh, this is even getting better. I'm going to go and just mirror this one just to make it look a little bit easier. Remember, the alligator still eats the 2.8. Okay, so I got my two statements. You see them? 1 and 2. I need to go and graph them. This is going to be a compound inequality. Let's get green. Remember, I like green. So on one end, we have -1, 0, 1, 2.8, and 3. I'll put -2 over here too. There you go. Let's do x is greater or equal to -1, so solid circle. Greater or equal to, so it's going to go this way. And I know x is less than 2.8, so that's an open circle. Oh, open circle. And I'm going to combine it. There we go. So I'm just saying, like, what does this show me? That these values, all these values, are what satisfy this compound inequality. So that's what the graph is actually showing. And that is compound inequalities. Thanks everybody for tuning in for another edition. Hopefully you learned something new about adding and subtracting inequalities. Go check out Multiplying and Dividing, subscribe, or go and do some good things. Until next time, have a great day.